Guys ready for some compositions of theorems? Yeah, we're all excited. Super excited. All right, let's dive in, all right? So here's a little warm up, a little bit of review of some of the junk we've done. Let's go ahead and graph this triangle first. All right, so triangle A is at 2, -5. B is at -1, -6. And C is at -3, 0. So this is the triangle right here. What a beautiful triangle it is. I love this triangle so much. Actually, if you guys want to know a fact about me, my favorite triangle is the right isosceles. Anywho, all right, so we're going to do two transformations. We got triangle ABC. We're going to reflect over y equals 1. Cool. Sir, yes, sir. Y equals 1 is this line right here. So let's just go ahead and count. C is 1 below, so C prime will be 1 above. B is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. A is 6 below, so it'll be 6 above. Nice. Okay. Now we're going to go ahead and translate this. Right 5 up 2. So just a matter of counting again. 1, 2, 3, 4, 5. 1, 2. Notice how I'm going to put C double prime. All right, because that's the next one in the thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. I almost lost count for a second. And then A, 1, 2, 3, 4, 5, 1, 2. All right, boom. Pretty cool. Hopefully you guys had fun doing that. All right, so we just reviewed a reflection and then a translation. Okay, now let's do the same exact thing. I'm gonna copy, I'm gonna paste and put this thing down where it goes. All right. Now, we're going to do the same exact thing, but we're going to swap the order. Okay, what I'm going to do is, first, let me go right 5 up 2. 1, 2, 3, 4, 5, 1, 2. C prime. 1, 2, 3, 4, 5, 1, 2. A prime. 1, 2, 3, 4, 5, 1, 2. Okay, and now let's go ahead and reflect this bad boy over y equals 1. All right, so C is going to be on the opposite side now. 1 above, 1 below. A is 1, 2, 3, 4. 1, 2, 3, 4. And then B is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Wait. Oop, somehow I was off one space on that. That's a little bit embarrassing, but poop. There we go, right here. 3rd time's a charm. I made that saying up. Okay. So, cool beans. Now, according to what you observed above, does order and transformation occur affect the final image? The answer is yes. All right, so the order we do things matters. Yes, order matters. We ended up in a different location. All right. Now it's oriented the same, but a different location. So order matters. Sometimes it doesn't, but just a good habit to do the specific order it tells you to do it in. All right, so let me think what I want to do here. We'll just knock out this page. Glide reflection. So we're going to be talking about compositions. So it's basically like we're going to reflect, then translate, or rotate, then reflect, or reflect and reflect. All right, we're just going to do a combination of transformations and see what happens. So a glide reflection is a composition of a reflection and a translation. All right, the translation is always in a direction parallel to the line of reflection. All right, so here is a good example. All right, we reflect over here, then we translate parallel to the line. This is a glide reflection. So which of these compositions of transformations are a glide reflection? We'll write yes, this one is. Now, have you guys ever looked in the mirror and then you look away from the mirror but your reflection keeps looking at you? Well, if your house is haunted, maybe that's happened to you, but no. Notice how this is not a reflection, not a reflection. You guys ever look in the mirror and your reflection is doing something different than you're doing? Very spooky stuff. All right, so this answer is no. All right, and then this one from blue to green, yes, we're reflecting, and then we're translating green to red in a direction parallel to the line, so this is another example. Cool beans. All right, so that's just kind of a warm-up what a glide reflection is. Now remember, this is how they make your favorite Disney movies, whether it's Finding Ralph, Wreck-It Dory, Cars Story, your favorite Disney movies. This is how they make it. All right. Perform a glide reflection over the x-axis and then write 6 units. Write a rule for the coordinate notation. Okay, so just for fun, this is unlabeled, but we're going to call that point A, and we're just going to focus on point A the whole time. So that's at -8, 4. And then it's telling us to reflect over the x-axis. Sir, yes, sir. So when we do this, also notice how this graph is counting by 2s, like 0, 2, 4. Well, those are negative numbers, but nonetheless. Just something to keep in your mind. So that A prime is going to be there, and we got that box, or that point, and that point. All right, so I've gone ahead and done reflected over the x-axis. Now A prime, for fun, is at -8, -4. All right, so it's telling us to write a rule for the reflection. Remember, some random point x, y. For reflecting over the x-axis, x stays the same, y becomes negative. And that's exactly what we observed above. All right, now it's saying translate 6 units to the right. So again, remember, we're counting by 2, so 2, 4, 6, boom. That's a double prime, and that's going to be located at, kind of cramming it in here, -2, -4. All right, and then let's do the same, 2, 4, 6, 2, 4, 6, 2, 4, 6. All right, and that was just our stereotypical translation. So we're going to use coordinate notation. All right, now why is a glide reflection so cool? Well, notice something. We can combine these rules, this orange rule, this purple rule, we can combine these into a single rule. Notice how in the translation, or excuse me, the reflection, only the y changed. And in fact, all that happened was we changed the sign. In the translation, only the x changed and we added 6 to it. So what I can do is bash these together. I can say, well, now I can write x, y arrow. Well, in both of them, we only went right 6, and then both of them, the y changed sign. All right, so that's a rule for the glide reflection. And in fact, notice how if we plug in A here, A, if we plug in -8, 4, and we go -8 plus 6, -4, we spit out a double prime, which was -2, -4. So plugging in a point into this glide reflection rule gives us our final point. Pretty neat. All right, let's knock out one more, and then we'll call it a video, and we'll pick up in another video. All right, so again, let's just focus on some point. Let's focus on this point. This point's a little quirky. We'll call this point J. J is an uncommon letter and no one realizes it. J is one of the most uncommon letters. All right, it's sneaky uncommon. Now we're gonna reflect over the y-axis. So let me do the same thing. I kind of like, this time I'm gonna write J down here so I don't have to cram it up anywhere. Now let's reflect over the y-axis. It's this one right here, cool beans. All right, so boom, boom, and then 2, right there-ish. All right, this one's counting by 2s. We're kind of in the middle of nowhere on some of these, but that's okay. All right, so now J prime is now at -9, 2. And remember, this rule for reflection, when we reflect over the y-axis, x changes sign, y stays the same, and that's exactly what we observed from J to J prime. 9 became -9, 2 stayed 2. All right, and now we're going to go 5 units down. Neat. All right, 2, 4, 5, 2, 4, 5, 1, 3, 5. All right, remember it counts by 2. Off the grid a little bit, but that's okay. And then J double prime. Where's J double prime at? Well, it's at -9, -3. And then recall, we have the coordinate rule for translations where we didn't move for the x and we just went down 6. So what's so neat about this is I can again bash these together. X changed signs, y stayed the same, x stayed the same, y went down 6, and I can write a single rule. I can say x, y, arrow, -x, y minus 6. And again, if I plug in 9, 2, for fun we'll plug in 9, 2 to this, and I go -9. Hold on, brain fart. Oh my gosh, brain fart from a long time ago. That was down 5. Oh my gosh, hopefully you caught my mistake. Hopefully you caught, oh, I'm so embarrassed. All right. All right. It's -2, or excuse me, 2 minus 5, and it spits out -9, -3, which is exactly where we should land. All right. Stay tuned for more.